All right, so we're going to talk about cylinders, cones, and spheres, specifically on how to calculate volume and surface area for both. So we have we have formulas that will be given to you, and the volume of any prism, the volume of any pyramid, the volume of any cylinder, and the volume of a cone are all here, and all of these will be provided to you during the test and final exam. But just to kind of go over the volume of any prism, the volume of the area of the base times depth, or length times height times width. Volume of any pyramid is the same, just divided by 3. The volume of a cylinder is pi r squared, which would be the base times the depth or the height. And the volume of a cone, because it would be part of a cylinder, would be the same area formula, the volume formula, and then just divided by 3. So, quick examples here. We are going to calculate the volume of each object. Well, I only have measurements for this one. I have nothing over here, so I'm going to assume that this is basically came out of here. So I end up getting my volume formula, which is volume is equals pi r squared h. My radius is 4. My h is 16, right? The radius from 8, half of 8 is 4. And then the height is 16. So all that together, I get a volume of 804.3. And then I go ahead, my formula for my cone is 804.25 or 804.3 divided by 3, which gives me a volume of 268 feet squared. Moving on to the over here, the pyramid. So volume equals area base times depth. In this case is 5 times 5 times the depth. In this case is 9. So it'll be 25 times 9, which gives us 225. Volume of my pyramid would be divided by 3. So 225 divided by 3 is 75 meters squared. Now we're going to talk about the surface area. So calculate the surface area of the cone to the nearest centimeter. So, well, I know my area of my base is pi r squared. So I go ahead and pi r squared, my radius is 4.1. I end up getting the area for the base here, which would be 52.8 centimeters squared. Now I go the area of the lateral surface. So basically the part of the cone that is not covered by this base. So that formula is pi r s. And that would be using s as the slant height. So pi times r times the slant height, which would give us pi times 4.1 times 7, 90.2 centimeters squared. And again, I'm looking for the whole surface area of the cone, which means I add those two together, and I am getting the surface area equal to 143 centimeters squared. Now we're going to calculate the surface area of the cone to the nearest square centimeter. Okay, so here's my cone. I have a radius of 3, a height of 8, and this is my slant height, which is s. So right away, we should be looking at, okay, we need to figure something out here. You could do it one of two ways. You could calculate the slant height first and then go ahead and figure everything out. Or you could calculate the area of the base, whichever one you wish to do. If you calculate the area of the base first, you end up getting a value of 28.27 centimeters squared because you know your radius of 3. Plugging it into your formula, you get your answer. The other piece of it would be finding that side length, or that slant length. So using the Pythagorean theorem, a squared plus b squared equals c squared, we end up getting the s value of 8.5. So now I have all the pieces to the puzzle. Now I just need to plug them in. So my area of the lateral, pi rs, pi times r times the slant height, 3 times 8.5 times pi, which gives me 80.1. Adding them together, I end up getting surface area of the total cone being 108 centimeters squared. So we have some sample questions, more some word problems here. The cone below is 20 centimeters high and has a total volume of 1,000 centimeters cubed. Which of the following is closest to the length of the radius labeled r? So I need to look at these pieces of information and identify which measurements or which pieces of the formula they are going to represent. So in this case, 20 centimeters high is going to be my h and has a total volume of 1,000 centimeters cubed, which means there's my volume. So if I know my volume formula for a cone, volume equals pi r squared h divided by 3, and I have my values, 1,000 is equal to pi r squared times 20 divided by 3, and I go ahead and solve for r. And how I do that is I take pi times, because this is still multiplication, pi times r squared times 20 is the same as saying pi times 20 times r squared. So I divide both sides by a factor of pi times 20. So pi times 20, I do the same on the other side here. So I end up getting, for my r squared value, 47.75. And then the opposite operation would be square rooting in order to get my r, or my radius value, which would be 6.9. And then of the options here, we have 6.9 centimeters as an option for the length of the radius. So another one, Zach measures the slant height of a cone-shaped cup and finds that it is 12 centimeters. Okay, so he measures the slant, it's 12 centimeters. The height is 10. Okay, the height is 10 centimeters. Okay, so I've already labeled, this is my slant height, this is my height, and this would be my radius here. So determine the volume of water in the cup if Zach fills it to the top. Okay, so I need to find a couple things first. I can't go ahead and do this because I don't have my r, so I need to find my radius value first, which I can use the Pythagorean theorem in order to do that. Whoop. Hang on. That's better. That's never happened before. Determine the work of the the volume of the water in the cup if Zach fills it to the top. So finding that radius length, 6.6, and then I can plug it into my volume formula, pi r squared h divided by 3, and I know those values. My radius is 6.6, my height is 10 divided by 3, and I'm getting the value for that volume, 456.1 centimeters cubed. All right, a few more word problems and we'll finish off. So, Pluto, which used to be considered the farthest planet, is now classified as a dwarf planet. The diameter of Pluto is approximately 2,290 kilometers. Calculate the surface area of Pluto to the nearest tenth of a square kilometer. Okay, so this gives us the diameter of Pluto, which means that the radius would be whatever 2290 divided by r is. Recognizing that the surface area of a sphere, 4 pi r squared, I find my r value by taking the diameter, dividing it by 2, and I just plug it in. So 4 pi, and then my radius value would be half of that, 1145 squared, and multiplying all three of those, I end up getting this as my kilometers squared, 60,474,826.03 square kilometers for Pluto, not the dog. Example 9. Determine the radius of a baseball that has a surface area of 215 centimeters squared. Round your answer to the nearest tenth of a centimeter. Okay, so I am given the total surface area, and I need to find the radius. So, using my formula, surface area equals 4 pi r squared. I know that my total surface area is 215, and now is set to 4 pi r squared. I need to solve for r. So, I divide both sides by 4 pi, and I end up getting r squared, which would be the same as taking the square of 215 divided by 4 pi, whatever the square root of that is, which would be 4.14, or the nearest tenth of a centimeter, which in this case would be 4.1. So the radius of that baseball would be 4.1, in this case centimeters. I should have wrote that here. All right, this is a bit of a tricky one. The surface area of a sphere is 36 pi a squared b squared meters squared. This is not a part of the equation, so I just kind of wrote that over here. This is what it means in meters squared, because we're talking about surface area, right? So, when I plug this in, I have my surface area formula. 36 pi a squared b squared equals 4 pi r squared, because we're looking for surface area. We'll divide both sides by 4 pi, because I'm looking for the radius. So I divide both sides by 4 pi, and I'm going to get things cancel out. Pi's cancel out, 36 divided by 4. So I end up getting 9 a squared b squared is equal to r squared. So I need to go one more step because I need to find r, the square root of both sides, and I end up getting my r value to be 3ab. So therefore the radius is 3ab meters. All right, a bit of a thinking question here. If a radius of a sphere is tripled, the surface area of the sphere will increase by a factor of 3, 4, 6, or 9. We need to figure that out. Well, if the radius of a sphere is tripled, the surface area, so that's my formula I need to be using. So surface area, when I plug that in, surface area equals 4 pi r squared. And then if I'm tripling the radius, so I'm multiplying r by a factor of 3, well then the surface area would be 4 pi times 3r squared. I can go 3r squared, which is 9r squared. Right? See how we raise that to the exponent? Because we can do that. So then we actually affect the surface area of the sphere by a factor of 9. And the last one, Earth has a radius of 6,371 kilometers. The moon has a diameter of 3,474.2 kilometers. Approximately how many moons could fit inside the Earth? So this is talking about radius, this is talking about diameter. Well, I need to find the radius of the moon. So if I do that, I take the diameter divided by 2, and then I'm looking for the volume of the moon and then the volume of the Earth. I ran out of space here and I didn't want to do those big numbers. So if we just basically talk about, okay, what is the volume of the moon and the volume of the Earth, and then how many moons would technically fit inside the Earth is basically what we'd be looking for. Or we're finding how many, take the volume of the Earth and divide it by the divided by the volume of the moon, we would have the amount of times that the moon can fit inside the volume of the Earth.